Okay, I've got 6 minutes to show you how to do a collapsible compass segment. So when we normally do a compass on paper, I have a segment, and the way that normally you would do a compass on paper is you would take your compass and you would do this, and you would take that same shape and you would draw that same size compass somewhere else. And in fact, in Desmos, you can actually use the compass tool, and if you click on the radius, it says, oh, you want something this size? You can go over here, and then you can say, well, you could actually connect it and say, okay, here's my duplicate, because these are the same size circles. And what's weird here is Desmos lets you do this. When you grab one end and make it bigger, magically gets bigger on the other one. Now, in the real world, this would never work, because on your paper, this would never happen. But they're kind of assuming something. So I'm going to show you a very old proof that Euclid did for doing this with a collapsible compass, where everything's kind of connected and you can't just magically pick up your compass and transfer a segment to somewhere else. So we're going to undo all that. Okay, so first we're going to create a segment BC, and I'm actually going to label it, because otherwise I'm probably going to do this wrong. I'm going to call that B, and I'm going to call that C. And just because my diagram is a little weird, I'm going to move it just a little bit so I can read my diagram. Okay, and then I'm going to create some random point A. Okay, point A is down here, and I'm going to label it point A. All right. So I'm going to try to create a duplicate segment of BC starting at point A. And it's going to be I think it's going to end up being parallel to this, but I'm not sure. And we can make it go in any direction with a couple other extra steps, but I'm probably going to run out of time. Okay, so the first thing I'm going to do, I'm going to connect B and A. And I'm going to flip my screens here a second to make sure I'm doing this right, and you may see that or not. And I'm going to create an equilateral triangle here. So the way to create an equilateral triangle, I'm going to take my circle / compass and do that, and then I'm going to connect all those, and that's going to be an equilateral triangle. And my new point here, because I have instructions, I'm going to label that D. Okay, so let's see. Now I'm going to create, and I'm actually just going to drag this out a little bit farther, so it's not quite there. So once again, I'm going to try to make something that's BC long at A. All right, so I'm going to outline how big is BC. Is this big? And from here, I'm going to connect. I'm going to do a line, actually. I'm going to do a line from BC through here. Notice I got that there. And from this to here. And it's going to create that. Okay. Now, my last step is I'm going to do one from the center of D. D right here. And I'm going to go out to which center? Oh, to right here. And no, is that right? No, to right here, I think. This may mess up. Okay. All right. Now, this final point down here is, and this is not right. Let's try it one more time. I think it's from here to here. That looks right. Okay. If I extend this on out from here to here to there, we're going to call that, I'm going to click on that point. I call that E. I can make it work. Why is it not working now? There E. I think if we want to label AE, which I have right there, in fact, I'm going to label BC. BC is that length. And I want to also label this right here, because I made it a segment, AE, that length. Hey, they are the same. Now, here's the moment of truth. If I grab this and make it longer, does this get longer? Hey, look at that. Now, this is always going to be in this direction. So there's another step that would be involved to say, well, how can I extend this one in any direction? That's a hint. How do I do that? That's all.